Our objective today says we can use the Pythagorean theorem to find the missing side of a right triangle. So we're going to be given two sides of a right triangle, and then we're going to use the Pythagorean theorem to solve for the missing side, okay? So we have some concept here. We have a right triangle. And a right triangle is classified as a right triangle because it has a right angle, a 90-degree angle, okay? And I can see the symbol is usually like a square on the corner. That's representing a right angle. So if a triangle ever has a right angle, we call it a right triangle. And then we have the sides next to it, or the sides creating the angle, I should say, are the acute angles. So like the acute angles right here are the other two angles. Together, the three angles have to add up to 180 degrees. So because this is 90 degrees, these two together have to add up to 90, which means they have to be acute. They both have to be less than or equal to 90, okay? And then we have the legs of the triangle. The legs are the sides that create the right angle, okay? The legs create the right angle. Okay, so the legs create the right angle. Those are classified as the legs. Whatever the two sides are that create the right angle, those are called the legs. Okay, and then we have the side opposite of the right angle that is called the hypotenuse. So this here, across the right angle, that is called the hypotenuse, and it's always the longest side of a triangle. Okay, so again, the hypotenuse is always across the right angle, is always the longest side of the right triangle, and then the legs are the sides that create the right angle. All right, so we're going to practice identifying the hypotenuse. So to identify the hypotenuse, the easiest thing you can do really is to first find the right angle. So we're going to, oops, I thought it was on the pen. We're going to find the right angle because right across from it is going to be the hypotenuse, right? So here is my right angle. So across from it, this side right here is going to be the hypotenuse. Now I'm just going to put HYP for hypotenuse. Okay, so you always want to find the right angle, but the side across from it would be the hypotenuse. Likewise with this one here, I have my right angle right here. So across from it, this side is going to be the hypotenuse. Okay, so you guys go ahead and try with this one. Go identify the hypotenuse on each triangle. Okay, go ahead and share with your partner, or double check, I should say. Okay, again, double check. The hypotenuse is just always across the 90-degree angle. Okay, that's going to be important today because in the Pythagorean theorem, the hypotenuse is going to be our longest side. That's going to be our side C. So we have now the formula for the Pythagorean theorem. So the Pythagorean theorem is this formula right here. A squared plus B squared equals C squared. A squared plus B squared equals C squared. And then notice I have my A and the B are the two legs, And notice here, A is on the vertical side versus over here, A is on the horizontal side. Likewise, B, I can call B the horizontal side. I can also call B the vertical side. It really does not matter, A and B. Like, you can switch A and B, but C has to always be the hypotenuse, okay? The C squared always has to be the hypotenuse. This is why it's very important for you to practice finding the hypotenuse. Is C always has to be the hypotenuse. You can switch A and B, but you can't switch C, okay? So you can switch A and B, but not C. Side C always has to be the hypotenuse. A and B can be switched. It doesn't matter which one's A, which one's B, because you're adding them in the formula. It doesn't matter because addition is commutative, meaning you could switch 2 plus 5 and 5 plus 2 is still 7, okay? So you can switch A and B, but you cannot switch C. The hypotenuse always has to be the C. Okay? All right. So now let's look at our first example. You should have it, I think, right underneath the Pythagorean Theorem. Yes? Right underneath it. We have the 3 and the 6 here. So in our first example, and again, I know you guys have done this before, and it's gonna feel dumb at me explaining it so much, but again, with the pandemic and everything, I don't know how much of you guys remember from this, okay? So I'm gonna go break it down really slow for this example. The first thing you want to do is identify the hypotenuse, and you're gonna label it as C, okay? So step 1, I'm gonna look for the right angle, and then across from the right angle is going to be my hypotenuse. So I know that that side is the hypotenuse, so 6, I'm going to label it as side C. Okay? Then step 2 is label the legs A and B. Label the legs A and B. And it doesn't matter which is A, which is B. I usually just go from left to right. So on the left side, I am calling it A, and 3, I'm going to call it B. But again, you can say 3 is A and the missing side is B. It doesn't matter, okay? Step 3 is you're going to use the Pythagorean Theorem, which is A squared plus B squared equals C squared. So just plug everything in. I don't have an A, so I'm just going to leave it as A squared. My B side, though, B is 3. So I'm going to go plus 3 squared is equal to the hypotenuse squared. The hypotenuse is 6, so I'm going to put 6 squared for that one. Okay. Then our step 4 is to then solve for A, or really solve for the missing side. Whatever side is missing, you solve for it. Okay. In this case, I'm missing A, so I'm solving for A. So I have this A squared plus, what's 3 squared? 9. Thank you. And 6 squared is 36. So my goal again is to get this A squared by itself. So I have to get rid of the 9. So how do I get rid of the 9? Subtract it on each side, right? So I have A squared is equal to 36 minus 9 is going to be 27. And then I have a squared. I don't want a squared. I just want A. So how do I get A by itself here? What did we do before ski week? How did we get rid of the squared? Square root each side. Good. We need to take the square root of each side. And then if you notice, the directions up here says it has to be in simplest form. So in simplest form, I'm going to have to simplify the radical of my square root of 27. I need to simplify it. So I need to see, is there any perfect squares that go into 27? So my perfect squares are 1, 4, 9, 16, 25. Those are the only ones smaller than 27. So do any of these go into 27? 9, yes? I can split this into the square root of 9 times the square root of what? 9 times what is 27? 9 times 3, right? And then if you have a perfect square, this square root of 9 is going to become a whole number 3. No more radical, it just becomes 3 because 3 times 3 is 9, right? So the square root of 9 is going to be a 3. And then just bring down the square root of 3. And then the square root and the square cancel. And it leaves you with a. So I have a is equal to 3 square root of 3. Or 3 root 3. Okay? All right, but again, this first example, I was just kind of just doing everything step by step. Identify the hypotenuse, label the sides A and B, and then you plug everything into the Pythagorean theorem, solve for the missing side. Notice in this case, I didn't write it down, but what I did here was subtract 9 on each side. That's because my two values were on opposite sides of the equal, so we subtract. Sometimes it might be on the same side of the equal sign, so you're going to add the numbers instead of subtracting them, okay? And then don't forget to simplify your radicals as much as possible. So we are going to have to know the perfect squares. I forgot to write them down somewhere on your notes, so you guys can just write them out yourselves. We are going to need the perfect squares, so go ahead and maybe just copy this somewhere. Like at the very top of your notes, you have some space. Actually, at the bottom, we probably won't do the very last example, so you can just do it on the bottom space there. We have perfect squares. We have 1, because the square root of 1 is 1, right? Then my next perfect square is going to be a 4, and the square root of 4 is 2. Then we have 9. The square root of 9 is 3. What's my next perfect square? 1, 4, 9, 16, because the square root of 16 is 4. And then we have 25. The square root of 25 is 5. We have 36. Square root of 36 is 6. What's our 7? 49. So square root of 49 is 7. Okay. Then we have 8. What's 8 squared? 64. Good. So my 64 is the square root of 64 gives us 8. And then 9 squared is 81. So the square root of 81 is 9. Then my 10 squared is 100. And then do you guys know 11 squared? 121. So square root of 121 is 11. And then 12 squared is 144. Good. Square root of 144 is 12. And then we also have the 13 squared. I'm not sure if you guys know them that far, but 13 squared is 169. So square root of 169 is 13. 14, I believe, is 196. So square root of 196 is 14. And then 15 is 225, I believe. 225 is 15. Okay. Those are usually the ones that show up the most. Occasionally, you'll have one that's bigger. Like, I think on the assignment, you have, like, a 26 squared, I think. So 26 squared will show up on the assignment today. 26 squared, I think, is 676. You also need the 24 squared is 576, I think. 24 times 24, I believe that's 576. Can you guys double check that? You guys have, you guys have your phone. 24 times 24, is that 576? I think so, right? Okay. And then 20, for some reason I skipped 25. 25 squared is 625? I wasn't expecting 625. But thank you. So anyway, so on your homework, those are like probably the biggest ones that will show up. 676 is 26 squared, 24 squared is 576, and 25 squared is 625. Okay? Those will show up on the assignment today, so I just wanted to throw those out there as well. Okay? All right, so let's keep this handy somewhere because you're going to need this when we're simplifying. All right, so let's go ahead and look at our next example. In our next example, I think you have to plug in the 3. Yeah, it looks like you're missing the 3 on your notes. So go plug in the 3 on the notes. The side here with the 4. We're missing the 3. Okay. So again, our step 1 is to identify the hypotenuse. So I need to figure out the right angle. Is right here. So across from the right angle, this is my side C. And then A and B, it doesn't matter which one is which, but I like to just go from left to right. So my 3, I'm labeling as A, 4 as B. You can switch those. You can say 3 is B, 4 is A. You'll still get the same answer. All right, so let's plug it into my formula. We have A squared plus B squared equals C squared. So my A, side A is 3, so we have a 3 squared plus B is 4, so 4 squared is equal to my C. I don't know C, so I'm going to put it as C squared. All right, 3 squared is what? 9, and 4 squared is 16. And 9 plus 16, 25. And then to solve for C, how do we get rid of the squared? Square root both sides. So square root cancels squared. I'm left with the C. Is 25 a perfect square? 5, yes. So 5 is equal to C is my final answer for this one. So notice in this example, my numbers were on the same side, so you end up adding those, 9 plus 16, right? Versus our first example that we had, the 9 and the 36 were on opposite sides, so you end up having to subtract, okay? So opposite sides, you subtract. If they're on the same side, you add them together, okay? And then this one is you didn't have to simplify the 25. Well, I mean, you didn't have to like simplify the radical. It just became a whole number. All right, go ahead and practice with this one now. You have the 5 and the 12. I'm not sure which side is missing, so go fill in whatever side is missing. It looks like it might be the 5. Maybe the 5? Okay. All right, so you guys go ahead and try this one, and then I'll go walk around and see if you guys need any help. All right, double check your answer here. The missing side was the hypotenuse. Across from that right angle is my C. It was missing, so I was missing the C value. A and B, it doesn't really matter how you label which one's A, which one's B. Notice here though, 5 squared is 25, 12 squared is 144. These are on the same side of the equal sign, so you add them together and you get 169. And 169 was one of our perfect squares that we talked about, so 169 simplifies to just 13. Okay? I walked around. Most of you guys got that correct answer, so good job. All right, go ahead and now try this one. I believe you're missing the 2, maybe? Looks like it. So don't forget to identify the right angle first. So across from that is going to be the C. And then 2 is A, and the missing side is B. Or you can say 2 is B, missing side is A. Doesn't really matter. Okay? So go ahead and solve this one and then simplify as much as possible at the end. This one, I think you do need to simplify the radical. All right. So my answer that I have on the screen here, go ahead and double check. Notice this time the 16 and the 4 were on opposite sides of the equal. So you have to subtract 4, and that gives you 12. And then you have to simplify the square root of 12. So you want to look for your perfect squares are 1, 4, 9, 16, 25, 36, and so forth, right? But you want to look for the ones smaller than 12. Out of those 3, which one goes into 12? It would be 4, right? So you split into square root of 4 times square root of 3. And then the square root of 4 is 2. So the square root of 4 becomes 2, and the square root goes away. And then you leave the square root of 3 because there's no perfect square that goes into 3. Okay? All right. I think I'm going to just stop there and let you guys work on the assignment the rest of the period. Okay?